Okay. Here in this problem, the switch is being closed at t equal to 0. Okay. So at t equal to 0 minus, the switch was open for a long time, isn't it? So that means at t equal to 0 minus, the circuit A was in, let's say, was in the past we are saying, was in steady state. Okay. So at t equal to 0 minus, okay, since the circuit was in steady state, C acts like open circuit. So with these 3 points in mind, we need to write the circuit diagram now. Okay. Write the circuit diagram at t equal to 0 minus, everybody. Write the circuit diagram at t equal to 0 minus. Therefore, at t equal to 0 minus, the circuit becomes. Can you write it now yourselves? Go on. Yeah. The circuit looks like what? At t equal to 0 minus, the switch is open, right? See, the switch is open switch. Fine. Then we have a resistor of 50 ohms. We have the capacitor which acts like open circuit. Okay. So this is open circuited capacitor. Fine. So across that capacitor which acts like open circuit, okay, a voltage drop would appear. A voltage drop would appear, that is V of 0 minus. Okay. And if there is a current flowing, that current flowing I should rather denote that as I of 0 minus. Right. So do you think I of 0 minus flows there? Do you think I of 0 minus flows there? This is 10 volts. Is I of 0 minus flowing? No, see, there is no connection with the source at t equal to 0 minus. That means I of 0 minus is not flowing. And similarly, there is no connection at all with the voltage source. This voltage will not come across this, though this is not flowing. Sometimes, see, if this is closed, if the switch is closed, okay, the current will not flow, but voltage drop would be there. Getting the scenario? The switch is, when the switch is closed, suppose like this, okay, let's see, suppose like this, it is closed, then I of 0 minus will not flow because capacitor is open circuited, but this voltage would drop across the capacitor. Understand? But what is this case now? The switch is open. See here, the switch is open. Okay, so the supply is not being given here. Get that point? The supply is not there. So I of 0 minus will not flow. Similarly, since the supply is not there, V of 0 minus would also not drop. Okay, therefore, we can say what? Therefore, we can say that this implies that our I of 0 minus is 0. Okay, similarly, V of 0 minus is also 0. Okay, now the question, this I of 0 minus is there, right, which is 0. So seeing this, can you say I of 0 plus is also 0? That is what is the thinking that you should do now. I of 0 minus is 0. Does that mean that I of 0 plus is also 0? If so, when would that happen? If it is not equal, why it is not equal to I of 0 plus? Anybody would like to comment on that? Anybody? Why here I of 0 minus is not equal to I of 0 plus? Let me ask you that. Let me tell you, it is not equal to. Why? Because see here, there is no inductor at all in this particular circuit. There is no inductor at all. There is only the capacitor. Understand that? Since this is not the current through the inductor, I of 0 minus is not equal to I of 0 plus. Finish. But what about this voltage? This voltage is the drop across the capacitor. Since that voltage is the drop across the capacitor, V of 0 minus would be equal to V of 0 plus. Okay, so let's say that this is just for your understanding. I of 0 minus is not equal to I of 0 plus, since it is not the current through L. First thing. Okay, this is something that you should understand. Okay, but V of 0 plus is equal to V of 0 minus. Okay, so it is 0 volts. Why it is true? Why this is true? This is true since V is drop across C. Make sense? Okay. Now we have been asked to find out I of 0 plus. Okay. I of 0 plus is not equal to I of 0 minus. That means I of 0 plus needs to be found out by considering the condition at what? T equal to 0 plus. Is everybody okay with that? So if you have written, just compare that with this. What's happening at T equal to 0 plus is what we need to look at. Okay. Now to find out I of 0 plus, to find I of 0 plus, we have to consider circuit at T equal to 0 plus. So how does that look like? With the switch closed. Okay. So that looks like this. 10 volts. Okay. Then you have switch closed. You have resistor. Okay. And now we are writing the circuit. Okay. Where it is not in steady state. So when it is not in steady state, C has to be considered like this, which is 2 microfarads. And this is 50 ohms. And what is dropping across this? What is dropping across this? V of 0 plus is dropping across this, mind you, at T equal to 0 plus. Okay. Now what is flowing? What is flowing in the circuit? I of 0 plus is flowing. So can we find I of 0 plus now by applying the KVL? So KVL implies what? KVL implies minus 10 plus 50 into I of 0 plus. Okay. Uh, Plus we shall directly write V of 0 plus, because we know V of 0 plus. In the previous step we have found out that. Okay. So algebraic sum of all this would give you 0. So this implies that our I of 0 plus would be 10 minus V of 0 plus divided by 50. Okay. So substituting V of 0 plus is 0. So this is 0, right? Okay. So what would this be? What would this look like now? This would look like 10 by 50. So 10 minus 0 by 50. Okay. So it would be 0.2 amps. So I of 0 plus is found out. Okay, to find out I of 0 plus, we made use of V of 0 plus, which is the voltage across the capacitor, and that we have found out in previous step, considering the circuit at t equal to 0 minus. Is this okay with you? Now what we need to do? What we need to do now? We need to find out what the first order differential and the second order differential. So what we need to do is applying KVL to find di by dt and d square I by dt square at t equal to 0 plus. We're again applying the KVL to the same circuit, okay? But we write it in a different way, okay? So what is that? Again, consider the circuit at t equal to 0 plus. So which we have considered already in the previous case. You need not have to write it again. Okay. But the equation that we write to find out the first order differential and second order differential is different. The integral equation we should write. So KVL, applying KVL, the same circuit. Okay. It is the same circuit, I mean. You need not have to write it. If you just understand, it is fine. Apply KVL. See how we have done the same in the previous case also, but the purpose was to find out I of 0 plus. That's why we wrote it as V of 0 plus, the voltage across the capacitor. Now see how the things differ with the context. It's I of 50 into I of 0 plus, right? Plus it's 1 by C integral I of 0 plus dt equal to 0. Is everybody okay with this? Now, where is the differentials? This is what we are looking at. Is it there? No, it is not there. So what we need to do on this? What we need to do? Let's call this as equation number 1. Let's call this as equation number 1. What we need to do to have the differentiation of I of 0 plus with respect to t, we need to differentiate this with respect to t. So what do you find? Go on, everybody differentiate that. So minus 10 you have, it would go 0 because differentiation of a constant with respect to anything is 0. Then 50 into differentiation of this plus 1 by C I of 0 plus, because the integral would vanish when you differentiate the equation. Okay, so this implies what? This implies that our di of 0 plus by dt is actually equal to minus 1 by C I of 0 plus divided by 50. What is C? C is what is C? C is 2 micros. 2 into 10 power minus 6. Okay. Then what is I of 0 plus? I of 0 plus we have found out to be 0.2. Okay. Divided by 50. So this is what is going to be your first order differential of the current I of 0 plus. So this is how it is. Fine. So this would be minus 2 into 10 power 3 ampere per second. Now we have got the first order differential of current I of 0 plus. You have to get the second order differential now with respect to t. What we need to do? what we need to do here on. Okay, so you can call this as equation number 2. Fine. So let's make a statement here. To find d square I of 0 plus by dt square, differentiate 2 with respect to t. Fine. So if you differentiate 2 with respect to t, what we're going to get? We're going to get this 50 plus, sorry, it's 50 into. Okay, 50 into d square I of 0 plus by dt. Okay, then 1 by c times di of 0 plus by dt, this is dt square, okay, equal to 0. Fine. So from this we can find out the second order differential. So this implies that, what does this imply? This implies that d square I of 0 plus divided by dt square would be equal to 1 by c times di of 0 plus by dt divided by 50. So it's 1 by 2 micros into minus 2 into 10 power 3, okay, divided by 50. Just take down this, everybody. So this implies that our second order differential, that is d square I of 0 plus by dt square, would be equal to what? What is this going to be equal to? So here this is minus 1 by c, right? Sorry, yeah. This is minus 1 by c, you have minus. Okay, that minus we are not supposed to miss. Okay, so what would that look like? That would look like 20 into 10 power 6 amperes per second square. Okay, so this is how the things go. Now take another problem which is very similar to what we have taken now. Okay, but it differs in just by the inductor. We had capacitor, right? So in place of capacitor we will have the inductor. Okay, this is problem number 12 for you. What is it? Plus minus, you have switch being closed at t equal to 0. You have resistor, but in place of capacitor you have the inductor. Okay, so this is 100 ohms. Okay, L is 1 Henry, R is this, and you have applied 10 volts. So what is asked? The same thing is asked. We have to find out I di by dt and d square I by dt square at t equal to 0 plus. So this you need to find. Fine. So I'll give you the answers. Okay, so you can solve it yourselves. Okay, the answer now, the inductor is there. Okay, so the current that you would consider is the current through the inductor, mind you, but it was not the case in the previous problem. Since the capacitor was there, the current that was flowing here was not actually current through the inductor. Okay, so that difference you need to consider. The answers. Just copy down the answer and get this yourselves, everybody. Your I of 0 plus is 0 amps. D I of 0 plus by dt is 10 amps per second. Okay. First answer, second answer. Third answer is the second order differential. And this is minus 1000 amperes per second square. Fine. Take a print screen or copy this down, okay, and get this yourselves.